All right. I don't know why, but I was kicked off. Hopefully, you can hear me. I should be back. I'm getting the screen back on now.
We can.
Okay, can you tell me where I left off when it kicked me off? I was talking, I think, about the continuity equation, basically. Given a pipe system, water flowing through the pipe, um, the rules of that state that the amount of water flowing per second through one part of the pipe must be the same as the amount of water flowing through another part of the pipe. And so if you, for instance, constrict a pipe and you have a gallon of water flowing through the fat part, well, you need a gallon of water flowing through the small part too. And since there's less room for the water to flow, it must mean that the water has to speed up. And so what we'd like is an equation that tells us if you constrict or expand a pipe, how does the velocity change? That's the continuity equation. And it says A1 V1 is equal to A2 V2, where A, of course, is the cross-sectional area of the pipe. How big is the pipe, basically? And so Bernoulli, in conjunction with this equation, allows us to solve all of those equations that dealt with pipe systems. Now, the big thing to note, of course, is you don't always need everything here. For instance, if you're reading a question, you have to be very careful that, well, for instance, I may give you the size of the pipe, tell you the pipe goes up to the second floor, and ask you what's the change in pressure in the water. Well, just because I gave you the size of the pipe doesn't mean the pipe will change size. And so I've seen in this class and other classes, when I've given a question like that and someone sees, oh, here's the, they gave me the first radius, didn't give me the second radius. So either they'll try to force using the continuity equation, or they'll send an email and say, hey, look, I don't think you gave us the information about the second radius. Well, here's the thing. First thing is, if you're unsure, definitely email me. I'd much rather you email me and say, hey, look, I think you should have given me this information, but I don't see it here. Am I wrong, or did you forget? Because it's quite possible I forgot. However, if I didn't forget, then I'll just tell you, no, actually, you don't need that information to solve the problem. Because it's true, there are times where you're given information in the problem that's not necessary. Just because I give you the size of the pipe doesn't mean you have to use it. The only time you actually have to use it is if the pipe size changes. Well, now you need to know about the radius. But if I don't say anything about the size of the pipe changing, then who cares what the size of the pipe is? And same goes for the height. If I tell you the pipe is on the second floor, 20 meters above the ground, and then it constricts, what's the change in pressure? Well, I didn't say the pipe went down anywhere. I didn't say it went from the second floor down to the first floor. I just said it's on the second floor. Who cares? So you don't need to know anything about the height. But if the height changes, then yes, you do need to know about the height, obviously. So just be careful about that when you're given a problem on the test. The data in the problem sometimes is not important. And if it's not important, then you don't need to use it. And like I said, if you're unsure, if you think, oh, he gave us the first height, didn't give us a second height, I think he was supposed to, then send me an email and I'll be able to answer whether, oh my God, yeah, you're right, I did forget to give some information or whatever. So that was Bernoulli with the continuity equation. We also had the pressure depth relationship. And what this one says, this is a nice equation that tells us how the pressure on an object changes as it goes deeper and deeper into a fluid. So for instance, you're a diver and you dive 30 meters under the water. And you want to know what pressure will you feel? Well, the equation, pressure, is rho, where that's the density of the fluid you're in. Obviously, if you're in water, you'll feel more pressure than if you're in air because water is thicker and heavier, and so it pushes on you harder. So it depends on the density, times G, 9.8, times H, where H is the depth. How deep do you go? The deeper you go, the more pressure you're going to feel. And of course, this brings to mind gauge versus absolute pressure. Because what we know is this: on Earth, we have an atmosphere. And because of this atmosphere, an atmosphere is gas, of course, and gas is a form of fluid. That means everything on the Earth feels a pressure because it's in the atmosphere. Now, sometimes that's important and sometimes it's not important. For instance, if I'm worried about a flat tire, I don't care about the atmospheric pressure. I don't care that when the tire is flat, there's still pressure there. Who cares? What I want is how much more pressure do I have to give my tire to make it full? Okay, that's gauge pressure. Gauge pressure is the extra pressure an object feels above its normal state. Absolute pressure is like the total pressure something feels. So that would be if I pump up my tire, well, I pumped it up to, 35 PSI. And then there's also the fact that the tire is in the atmosphere. So I have to add in atmospheric pressure too. Or if I'm a diver diving under the water, how much pressure do I feel due to the fact that I'm under the water? That's gauge pressure. Or I can ask, what's the total pressure felt by the diver when he goes under the water? Well, then it's the gauge pressure plus atmospheric. And so the way this looks is absolute pressure is the atmospheric pressure, the standard pressure everything feels just being on Earth, plus the extra bit, which is called gauge pressure. And for instance, this equation, the pressure-depth relationship, is a form of gauge pressure. All this says is how much extra pressure do you get, which is the gauge. If the question said you're a diver diving 30 meters under the surface of the ocean, what's the total pressure felt by the diver? Then, I'm looking for absolute pressure. If I don't say that, if I say you're a diver that dives 30 meters under the surface of the ocean, what pressure do you feel? Then you assume I'm asking for gauge pressure. Okay, I'll be specific if I want absolute pressure. If I don't get specific, then what I want is the gauge pressure. So that was fluids. That was our second test. The last big topic is what we started towards the end of the semester, which is on light and optics. So with light and optics, what we had firstly was basically, what do we know about waves in general? So information about waves. We had things like the velocity of a wave is the frequency times the wavelength. That's a big relationship that's important to know. And of course, we also know that there's a special velocity out there, the speed of light. Light. And the speed of light is called c, and it's 3 times 10 to the 8th meters per second. Okay, something you should know. But every wave has a speed. even if it's not light, sound waves, 343 meters per second, and so on. Now, there were other relationships too. There were things like the period of oscillation, capital T. That's just the inverse of the frequency. If you know the frequency, 1 over the frequency gives you the period. We also had things like the angular frequency, which is just 2 pi times the linear frequency. Okay, just a new variable. It's still something like frequency, but now it's frequency times this number for whatever reason. K, called the wave number, that's related to the wavelength, 2 pi over lambda. Now, why did we want this omega and this K? It was because it makes the next equation a lot nicer to look at, the next equation being the functional form of a wave. That is a single equation you can write down that tells you everything you need to know about the wave. And it says the height of a wave at a specific time and place is given by the maximum amplitude of the wave, that is the maximum height of the wave, times sine of kx minus omega t. And so you can have a question like a wave moving with a speed of 500 meters per second has a wavelength of 0.5 meters. Write down the functional form of this wave. And so you'd say, okay, well, I know the velocity of the wave and I know the wavelength. What I need is A, and I'd have to tell you the maximum amplitude. I need A, I need K, and I need omega. Well, K I can get very easily. I already know the wavelength, so 2 pi over the wavelength is K. Done. There's that number. What about omega? Well, omega is 2 pi times the frequency. So what I need is the frequency. I'm given the speed and the wavelength, so I could use the other relationship, velocity is frequency times wavelength, to get the frequency. Once I know that, I multiply that by 2 pi, that's omega. And so you see, these types of questions are all about these relationships. Here's some pieces of information. Can you find these other pieces of information from them? And then the last thing was polarization. And with polarization, what we had was, here's some light. The light is polarized in a certain direction, and you're going to send that light through a series of polarizers, polarizing filters, let's say. And the question is, how much of the light will make it through the filters? And for that, we use the law of Malice, which says the intensity of the light that makes it through is the initial intensity of the light. So however bright the light was originally before you even sent it through, times cosine squared of theta, where theta, as the angle, is the difference between the angle of the light trying to make it through and the angle of the polarizer itself. So if the light originally is polarized vertically at 90 degrees, and the filter is a filter that's polarized at 30 degrees, then you'd say, okay, light's at 90, it's trying to get through something that's at 30, so 90 minus 30 is an angle of 60 degrees. So 60 would be the angle I'd put in for theta. And then, of course, if we have more than one filter, if we have 2 or 3 or 4 filters, one right after the other, and I'm trying to send the light through all the filters, well, you just, for each filter, you're going to multiply another cosine squared theta. The only other rule to remember is that if you happen to have unpolarized light at the beginning, then the only change you're going to make is that the very first filter does not get a cosine squared theta. Instead, it's equal to a half. But every other filter after the first one does get a cosine squared theta. So it'll be a half times cosine squared theta 1 times, theta 2 times cosine squared theta 3 and so forth. So for all cases, every filter gets a cosine squared, except the one special case, which is you start with unpolarized light. So the first filter does not get cosine squared, it gets a half instead. Every other one gets a cosine squared. And that's it. Those are the topics. So we see 3 major overarching topics: light and optics, fluids, and electricity. And of course, for each one of these topics, there's several subtopics. And like I said at the beginning, you can expect, since this is a 2-hour exam rather than a 1-hour exam, about twice as many problems. And so probably you'll get at least one of each problem. And in some of them, you may get 2 questions. Now, how to study, best way to study. Well, firstly, you've already seen my tests, and I made the final exam as well. So you know how the final exam will look. It'll look the same way as the old tests. No difference there. And the questions will be the same. Obviously, they're not going to be identical, but the wording, the look, all of that will be the same. And in fact, if I felt the questions were important enough to put on your old tests, then likely I still feel they're important enough to put on this test. So if you were to ask me what's the best way to study given a limited amount of time, first thing I would do is say, number 1, look back at your old tests and rework them. Get a blank sheet of paper and take those tests again and see how you do. If you do well, then you'll do well on those parts on the final exam as well, because the questions will be very similar. Of course, with light and optics, we didn't have a test on this, so it's a matter of looking at the practice problems that are posted and the solutions and see if you could work those practice problems. If you can handle the types of problems that were posted on the Canvas, then final exam problems should be easy as well, because it'll be the same types of questions. Nothing new or extraordinary, something you didn't see in class. It's going to be the same stuff we've been doing. The types of examples I work in class, that's what you can expect to see on the final exam. All right, so that's all I have for the final exam review. Do you have any questions for me about this upcoming final?
When is it and how are we taking it?
Sure. It is Friday, May 6th is the date for our particular exam. And we're going to do it online. So we were planning on doing it online anyway, but now with the university's COVID rules, and there seems to be a slight uptick in the number of positive cases and things like this, the university is asking us to do things online for the final exam. So we'll basically handle the final exam exactly as we handled the previous exams. I will post the exam in the morning, Friday. You'll download it, work it out, either on the test paper itself or on blank sheets of paper. Work it out, and then submit it back to Canvas by 11:59 p.m. So you'll have the full day to work on it. And so just as you did the previous tests, you're going to do this exactly the same way. The only difference being that this is a longer test since it's the final exam. Now, I'm not going to make the final exam, super long just because it's online. I'm making the exam as if you were taking it in class. So it's just a 2-hour exam. So you can expect it to be about 12 to 15 questions. That's like twice as many as a regular test was. But it is held online, just like our previous tests were. So there shouldn't be anything new there. But what it does say is, if you, well, to avoid any potential technical issues, especially for the final exam, try not to wait till midnight to submit it. Submit it by 10. That way, if there is a problem, then you can email me and say, hey, look, I just tried submitting it. The Canvas isn't working well. What do you want me to do? And then I can tell you specifically, email me a copy and then try again later, but at least I have a copy of it to know he wasn't late or she wasn't late turning it in or whatnot. So basically, we're going to handle the exam just like the previous exams.
Perfect. Thank you.
Mm-hmm. Any other questions? Now, of course, I'll post this stuff onto Canvas just like I do with the other stuff. So you'll have the final exam review posted. It looks like because I was kicked off a little earlier, the video will have to be in 2 parts, unfortunately. But certainly these notes will be posted to Canvas. So if you missed any of it or you want to go back and look at it, that'll be there for you to look at. But definitely my biggest recommendation is look back at the old tests, rework them as if you're taking them again, and the practice problems that are posted. If you could do those, you should get 100 on the final exam because it'll be the same types of questions, nothing new. Other than that, little things, definitely if during the test, and I'll repeat this in the email, during the test, if you have any questions, if you're unsure about something, or if you think piece of information is missing or something like that, don't hesitate to email me. I'd rather get an email that there is no problem rather than for you to not realize that there was a problem that I could have fixed. And also, as you're studying, if you have any issues, if you're confused about something and you want to talk it over with me, send me an email. Take a picture of the work, say, look, I'm working on this, but I don't know where to go from here. And then I can help you out with it. And if I need to schedule a Zoom meeting to do it more in person like that, then we can do that as well. So don't hesitate to use me if you have to as you're studying for this stuff, because believe me, I'd rather have everybody do very well on this test because it makes my life a lot easier when I'm having to grade. And so I don't mind having good grades because it makes grading a lot easier. So feel free, ask me questions as you're studying if you're getting stuff wrong or you don't know why you're not matching the answers as you see on Canvas, things like that. Other than that, Friday morning, I will post it, send an email to remind you it's posted. You can start working on it and so forth. But that's about it. So if you have no questions, you're free to go.